In lesson 3-3, we worked on noticing how large the quotient would be. And that's going to vary. One thing we know for sure is that the quotient may have the same number of digits as the dividend, or it may have fewer digits. So it's important for us to notice what size multiplier is our largest multiplier when we are working with expanded notation form of division. So we're going to look at a couple of examples. How many 4s are in 868? I'm noticing that my dividend has 3 digits, 3 places, and my largest place is the hundreds. So I want to make sure that I know where to start with what size multiplier. So I'm going to check first if I have a hundreds multiplier. So my group size is, I have to make size of 4. And when I am asking myself how many 4s are in 800s, I'm just sort of ignoring those other digits, just looking at this largest place. Can I make any groups of 4 out of 8? Well, certainly I can, because this divisor is less than my first digit in my dividend. So that's telling me that I will have the same number of digits in my dividend, in my quotient, as I do in my dividend, because I will be able to take at least 100, maybe more. So I'm in the hundreds place. So how many 4s are in 800s? Well, 4 times 2 is 8, so 4 times 2 hundreds equals 800. Subtract out that chunk from the dividend, and that leaves us with 68 still in the dividend. Since that is greater than the divisor when I'm comparing, it's telling me I can keep on dividing, and I'm going to check for the next lowest place for a multiplier in the tens. So right now I have 68. How many 4s are in 68? So when I'm thinking of this, 6 tens. How many 4s are in 6 tens? How many 4s are in 6? Well, this is less, so I can take at least one group. That one group is the size of 10. So 10 times 4 is 40. I can check 20 times 4, but that is 80, which is too big. I can't have more than what is left in my dividend. So 10 is my next multiplier. 10 4s are 40. I subtract, and I'm down to 28 in the dividend. Division is repeated subtraction. So my dividend is shrinking as I am stacking up my partial quotients. How many 4s are in 28? That is a basic fact I know, and that's going to come out to be exactly 7 1s. 7 times 4 is 28. No remainder. It's definitely less than the divisor. Nothing to bring up. 200 plus 10 plus 7 gives me 217 for my quotient. So this problem is an example where my quotient has 1, 2, 3 digits, just like my dividend started with 1, 2, 3 digits. That isn't always the case. Let's look at another example where we're going to have fewer digits in the quotient than in the dividend. So we have, again, a dividend with 3 digits, but do we have 3 digits in our quotient? Let's see. How many 4s are in 332? Well, my largest place is hundreds. I'm going to check how many 4s are in 3. Now, wait a minute. If I only have 3 of something, can I make a group of 4 of those things? Now, it doesn't matter what that is. In this case, it's 300s. The important thing is 3 is less than 4. I can't make a group of 4 anythings if I only have 3 of those things. Okay? So this is telling me no hundreds multiplier in my partial quotients. That means, and I can double check that, 100 is the fewest hundreds I could take. 100 times 4 is 400, which is bigger than my entire dividend. That's how I know I can't take any hundreds. That means I'm now going to look for a tens place multiplier. So now I'm going to look at how many 4s are in 33 tens. Oh, I can take groups of 4 if I have 33 of anything. In this case, I have 33 tens. How many 4s are in 33 tens? Well, I'm going to think of those basic facts again. I can start with my lowest. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. And if I go up one fact at a time, eventually I'm going to get as close as I can to 33. However, if I know my facts really well, I'm going to recognize that the closest basic fact to this is actually 4 times 8 equals 32, because I know my facts. But it's not 8. Remember, these are 33 tens. We're in the tens place. So it's 8 tens, or 80 is my largest multiplier in the tens place. 84s are 320. Subtract, leaving me with 12 in that dividend. Dividend shrunk a lot. How many 4s are in 12? I know to keep dividing because 12 is still bigger than 4. I can take exactly 3 groups of 4 from this 12, using them all up and having no remainder. Here, I only have 2 partial quotients to add. 80 plus 3 is 83. So this 3-digit dividend resulted in a 2-digit quotient. Do you see the difference? This 3-digit dividend had a hundreds multiplier, so there were 3 digits in that final quotient. This one does not. Again, you may have the same number of digits, or you may have fewer. Let's look at an example with 2 4-digit dividends and see how we can notice what our largest multiplier will be and how many partial quotients we will have. How many 3s are in 4 thousands? Can I make a group of 3 if I have 4 whatevers? It doesn't matter what it is. In this case, it's 4 thousands. It could be 4 brownies. It could be 4 cars. It could be 4 flowers. I could form a group of 3. Okay, so how many 3s are in 4,000? Are there at least 1,000 3s? Well, sure. 1,000 3s are 4,000. I haven't gone over. Are there at least 2,000 3s? Well, 2,000 3s would be 6,000, and that puts me over. Can't go over what I have. This is all I have. So my first multiplier is in the thousands. So this is telling me this quotient will have 4 digits, just like the dividend has 4 digits. 1,000 3s are 3,000. Subtract, and what's left in the dividend is 395. How many 3s are in 395? Well, I know that if I cover this up, I'm going to look for a basic fact that comes as close as we can here. How many hundreds of 3s are in 300? 100 3s would be 300. 200 3s would be 600, and that's way too big. 100 3s are 300. Subtract. My dividend is shrinking. It's now gone from 4,395 down to 95 with my groups that I've taken out. How many 3s are in 95? Thousands, hundreds. Now I'm checking for a tens multiplier. How many 3s are in 95? Well, how many 3s are in 9? 3 times 3 is 9, or 3 times 30 is 9 tens, 90. Can I go to 4 or 40? 40 times 3 would be 120, too big. So I know it's 3 tens, or 30. 30 times 3 is 90, down to 5. Now, how many 3s are in 5? This comparing step that we do after each subtraction is important because, This is telling me when I have a remainder or whether I have to keep dividing. Since 5 allows me to make at least one group of 3, that's telling me keep going. So now how many 3s are in 5? 1. 1 times 3 is 3. 5 minus 3 is 2. Is 2 less than my divisor? Yes, indeed it is. This is how I know I can stop dividing, because it's now my remainder. It's left over. I cannot form a group of 3 anything if I only have 2 of that thing. Okay, I need at least 3 things to form a group. This is called my remainder. To add them up, 1,131 with a remainder of 2. So this 4-digit dividend had a thousands multiplier, which means it ends up having 4 digits in the quotient, just the same number as the dividend. Okay, and how about our next problem? Sorry, I'm all over the place here. Another 4-digit dividend. How many 6s are in 2? Well, in this case, it's 2,000s. It could be 2 brownies. It could be 2 houses. It could be 2 cars. I cannot make a group of 6 of anything if I've only got 2 of it. So I cannot form any groups that are in the thousands. I can't make a group of 6 if I'm only looking at 2 of those things. So there aren't any thousands in this quotient. So we're going to have fewer than 4 digits, fewer than the dividend. So what do? I check and uncover another digit. Now I'm in the hundreds. How many 6s are in 25? Remember, these are 25 hundreds, but it doesn't matter. Really what matters is, can I form any groups of 6 if I've got 25 things? Yes, I can. Well, how many? What's the most groups I can form that are a size of 6? Well, I know my 6's facts, and I know that 6 times 4 is 24. And if I go to 6 times 5, I'm going to be over at 30. So the closest I can get is 400 6s. Remember, this is 25 hundreds. 400. Those zeros are important. 4 times 6 is 400 times 6, 2400, shortcut that we have been using for lots of things this year. Subtract out, and what is left? 176. So my dividend keeps shrinking through repeatedly subtracting out equal groups. First, I subtract out 400 equal groups of 6. Okay, how many 6s are in 176? I can cover up that last digit, and it helps me to spot what's the closest basic 6 multiplication fact that gets me as close to 17 as I can without going over. Okay, so we want to have a strategic starting point. I wouldn't want to say 6 times 10 is 60, because I know that's too big. 6 times 1 is 6, that's too small. So I want to think about my 6 facts. The first one I notice in my head is, I know that 6 times 3 is 18, but 18 is just 1 too big. So I'm going to drop it back to 2. 2 times 6 is 12, but this isn't a 17, this is 17 tenths. I'm in the tens place. So it's really 2 tens, or 120. Subtract, leaving me with 56 in that dividend. How many 6s are in 56? Oh, I don't have to cover any digits up because that looks like a 2-digit, close to my 2-digit facts. Let's see, 6 times 9 is 54, and 6 times 10 is 60, it'll be over. So 6 times 9 takes me to 54 with 2 left. 2 is less than my divisor. I can't make any more equal groups of 6 if I've only got 2 things left. So that tells me stop dividing. This will be brought up as a remainder. Add my hundreds, tens, and ones together. 400 plus 20 plus 9 is 429 with a remainder of 2. This 4-digit dividend resulted in 3 digits in the quotient. So we want to be on the lookout for what's the size of that quotient and how do I know what place it will be in. We don't want to just be throwing our zeros around without thinking about where they're coming from. Okay, I hope that helps you.